Thank you. Good afternoon. So as Sonali mentioned, I do have a background in design. I'm actually more of a creative director, but for the last 20 years, I've really focused on balancing kind of technology and design. So I have a really strong interest in both. So Velocity is my favorite conference because it really brings those two areas together of not only the data, but how we visualize it. And I had an interesting experience recently in Barcelona at the last Velocity session where I snuck into a few of the Strata sessions, which, as you know, is like the big data conference. And it was amazing to see all these data scientists completely orientating to the graphs and the visualization talks, because it's actually how you express all that big data in a way that you can communicate is really important. And that's really a key thing that I want to do today. So there's kind of three things I want to cover. Firstly, I want to explore some examples of visualizing performance data and what makes those examples great. And then I want to share some techniques and approaches that I use as a design process when visualizing data and building the stories around those visualizations. In particular, I'm going to pick apart the classic performance waterfall chart and show how we can manipulate it to highlight different aspects of a web page's performance. And overall, what I really want to do today is encourage you all to start thinking about the teams that you're in rather than the data. Think about the organizations you're in and how you can use visualizations to engage the wider teams around you and tell really great data stories about the performance challenges you face with your products. And so to set this up, I love this kind of quote, BC, I think of it like before technology as well. But, Confucius kind of said here, why data visualization is so important. When we talk about the speed of things, we're often talking about shaving off milliseconds here and there. We're using all sorts of acronyms and shorthand in our language to communicate different performance strategies. It can be really hard to understand what someone is talking about without a visual representation to give them context. And even more than that, it's only when we really start interacting with the system and manipulating the code that we fully understand its impact on performance. We have to see it, then we have to get involved through actually manipulating the inputs and seeing their effect on the outputs of a system to actually really understand it. Now, Brett Victor does some amazing experimental coding tools, and he takes this idea of involvement as the key to understanding and creates those great tools that give you a direct connection between the code and a visualization, allowing a user to explore and play with the inputs of that data and really understand it through directly kind of manipulating it themselves. So I've got a very short kind of demo here. It's really worth kind of taking a look at this if you haven't seen it already.
So what I have here is I've got this picture on this side and the code on this side. And this part draws the sky, and this draws the mountains, and this draws the tree. And when I make any change to the code, the picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture.
Oh, yeah, sorry, we should have some video there.
And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code other than typing. So for example, this number here is the length.
Sorry, I'm not sure what's going on there. Let's just try that one more time.
So what I have here is I've got this picture on this side.
Sorry.
And the code on this side. And this part draws the sky, and this draws the mountains, and this draws the tree. And when I make any change to the code, the picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture. And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code other than typing. So for example, this number here is the length of the branches. If I want to control that number, I just point my mouse to it, hold down the control key, and I can dial it up and down. So I can see what it looks like for big branches or small branches, and I can kind of converge on what feels right to me artistically. And this works for any number of the code. I just point to it, dial it up and down. And some of these numbers here, I know what they do, but it's still kind of surprising to see them do it. And other ones are just completely surprising. So down here, I've got this for loop where I'm counting to 16. I'm putting 16 little pink blossoms on every branch. And I can turn that down for less blossom or turn it up for more. But look at what I'm doing here. I'm just kind of moving that number up and down around 20 or so. And it has this really interesting shimmering effect. It kind of looks like the wind is blowing through the tree. And the first time I saw this, I immediately started thinking about how I could use this effect for an animation. How would I ever have discovered that if I had to compile and run between every change? So much of art, so much of creation is discovery, and you can't discover anything if you can't see what you're doing.
So I think that's a brilliant example of that direct connection and the playfulness that comes out of manipulating code. I know that was a tree, but imagine if that was your systems that you're architecting and kind of booting up and manipulating them, and if you could have that sort of experience, what sort of other ways of solving problems would you find? So now I want to explore a few examples of data visualization and the sorts of stories we can tell with them. Often it starts with this, which are just logs with thousands of lines of metrics. And our job is to turn them into a visual representation so we can see the patterns. So Brendan Gregg, who's sitting up the front here, who's going to critique me if I get this wrong, has done some amazing visualization work over the years. And here we see a technique of his called frequency trails, which shows disk I/O plots from 100 servers. In the top half of the graph here, you can see cache misses and the delay while the disk spins up versus the cache hits in the bottom. And so collapsing all these 100 servers together into one visual gives us a really easy way to compare and identify patterns of usage and where issues might be, not a single number on the graph. In this example, we see a colony graph, which is actually 300 servers or 3,500 zones in a data center. Now, without any technical knowledge at all, you can start to pick out textures, changes in color, and you can start to identify servers that have issues. Now, there's a number of dead servers in the middle here that you can probably clearly see. There's a few green ones down here with the big concentric circles. Those were servers with a cron script that was stuck spawning hundreds of processes until that server was out of its resource limits. So quite technical information encoded as texture can paint that entire story of a data center and allow us to quickly identify and monitor patterns. So there's a really important relationship between the data and the way that we choose to visualize it and the stories we can get out of that. And how we visualize is really important, and the way that we decide to transform that information. Here we see a step-by-step diagram of Brendan's thought process behind creating a heat map of disk latency. The translation of height into color intensity allows us to shift the form of the data and see it represented over time. So we move from something like this, where we see a drift in latency, but it's hard to quantify, and our y-axis keeps changing as well. What does this actually mean? We can turn that into a static heat map that allows us to easily see those patterns over time and understand how the latency is drifting. So here, the change in visual form from the height of the bar in the graph to a color intensity allows us to change one of the axes to time and helps capture and make that performance story visible. Now, here's a number that I have to confess I've really struggled with. So Pat from Web Page Test has devised an exceptionally great way to measure the user experience of a page load. It's a great alternative to the internal browser events, and it keeps us focused on what a user actually sees as the page loads. But to be honest, when I first saw this number, I didn't really know what it was. Was it a point in time? What is it actually measuring? It feels very abstract till I saw the visual explanation of where this number comes from. So web page test, as many of you know, and it's such an amazing tool. The thing that's probably most amazing about it is the core premise that it actually videos the page as it loads. So between 30 and 60 frames per second, web page test is just recording exactly what a user would see on screen. And so there's all sorts of analysis we can now do with those videos. So here we see a page load. And we can see that we can calculate a visual completeness score as to how visually complete that viewport was between 0 and 100. And we can graph those over time. So we can see here on the left that the page gets loaded very quickly, and it very quickly jumps to 90% visually complete, and it still takes a while to come in. Whereas on the right, it jumps to only 20%, and it takes a while for all the rest of the assets to get loaded, and then it becomes visually complete. So, and the thing that you can see here is that speed index is actually a calculation of the volume of time that is above the curve. So it's not a point in time at all. It's more the volume of time that the page was visually incomplete. So a little bit of an abstract concept, but it's a number that represents that journey from 0% visually complete right through to the viewport being full, and tells us a lot about the user experience. And it's really interesting because you still see a lot of people misquoting a speed index score of 1,000, misinterpreting it as 1,000 milliseconds, that the page was visually complete in 1,000 milliseconds. That's a totally incorrect interpretation of this number. And I think this is a great example of a number that means nothing without its own visualization. That first number, like, I don't know, it's just a number. But it's only like seeing this context and understanding where it comes from that you can give it that history and that meaning. And I think this is a great reminder that when we present metrics, we need to be careful that we're not presenting something too abstract, or we're taking something away from its context and its meaning becomes lost. So we always need to think about how much background knowledge our audience has. And then, of course, we have the waterfall performance chart, which I'm going to take a crack at sort of reimagining today, which lists all our resources. You should all know and kind of love this. You get it in the Chrome DevTools as well. We're using coloured blocks to represent connection states and content types. We can see when resources start and end, and the vertical lines show us things like when the page started rendering, how busy the CPU is, and all that good stuff. So what's great about all these examples is that they tell a story about a performance issue. And for me here, the point is not data, it's kind of stories is what we need to create to get buy-in from our organisations. And so those stories help us understand a sequence of events, and they're easy to remember. You can retell a story, it can travel through an organisation, it has themes, and quite often they're simple enough that they can clarify a particular issue, and they can travel as a story from person to person throughout an organisation. So before we can start to pull apart the waterfall, we need to think about who this visualisation is for. As matching your visuals to your audience is crucial. You really want to consider who's around your campfire and how scary that performance story should be. Whether you're talking to developers or the CEO, you probably want to change the story slightly. So there are a number of different roles within an organisation that care about performance, and they can all have very different questions. Here's just a few examples. So how much should I spend on performance? How soon is the website usable? How does performance change across different screen sizes? Is performance hurting our sales? What's the critical rendering path? Are we faster or slower than our competitors? So you can't answer all these types of questions with one simple visualization, or even the same set of metrics. People have varying abilities to interpret numbers based on their prior knowledge and experience. So pretend you're not kind of in the performance community. If you put a number like this in front of just an average person on the street and you ask them, is 6 seconds fast or slow? What do you think the answer is going to be? Some people are going to say fast, some people are going to be slow. A number in isolation without context doesn't have much meaning. And so to appreciate a number's meaning, you need to give it context. And here in this example, we've used colour, we've used emotive labels, we've given it references to other points in time, and we've tried to provide some meaning for what that number actually means. And we can see now clearly that the 6 seconds is way, way too slow. And so while a number alone can be tricky to interpret, the one thing that we all have in our favour is that we are visual creatures, right? And when we sit around that campfire together, there is a common set of cognitive traits and abilities that we can all tap into. So I love this as an example, but patterns, texture, colour, form, they're all used by artists and designers as a shorthand. Here Seurat, a famous pointillist, is using just a few brush strokes to hint at the human form, and yet we all really easily see 2 women sitting by a river. Now, in fact, our brains are actually hardwired to convert form into meaning, even when there can be none. So this 1976 image had many of us kind of believing that ancient aliens had built face-shaped pyramids on Mars. Woo, I wish. But yet, once we went back and we got a bit more detail, and we added some altitude data and perspective, we could now see that it was simply our desire to create some meaning out of some well-paced shadows. But our brain, which is wired for face recognition, it does this with all sorts of kind of household objects and shadows in all sorts of places. So we constantly hunt for those recognizable patterns around us and project meaning into them, and we can use that in our visualization work. So our brains are wired to scan for these patterns and changes and textures and colours. I wanted to use this combination of thinking about those patterns, thinking about our different audiences and those different performance stories that might come out of that. Now, all the visualizations that you see today are based on the amazing data that comes out of web page tests. There is a wealth of kind of metrics behind web page tests. If you're only ever used like the GUI in the front end, you're really missing out because there's a massive JSON file behind every one of those tests that you run, which has a wealth of data, and it's a massive, often megabytes worth of JSON, which is there and it's sitting there and it's really easy to kind of work with and manipulate. So part of what I want to do today is encourage you all to be creating these sorts of visualizations. Now, the data is commonly expressed like this in a waterfall chart. And before we get into the examples that I've created, I just want to take you through the thought process that I use when exploring these visualizations and how I tackled them. So in this example, like a frustration that I often have when using web page tests is that when I'm looking at a page with a lot of resources, and unfortunately, having worked in ad agency kind of land, we have pages with hundreds and hundreds of retargeting pixels and ad requests, and so we get pages with 400 or 500 requests on them. And so scrolling up and down and trying to use web page tests to understand what's happening in that waterfall chart can be quite difficult. So we can try scaling back, but then we start to lose the detail and the chart starts to get really noisy. So the approach I took for this project was not really to focus on the numbers themselves, but use more of a design and a visual kind of based methodology. I wanted to strip back the complexity and focus in on using just very basic forms and colours and shape to explore the relationship in the data and help me kind of understand and sort of intuitively understand the construction of a web page. I wanted to get a feel for it rather than necessarily know its explicit metrics. So here's an example of focusing in on just that front edge of resources so the overall shape of a waterfall can be more clearly perceived and scaled down. With a simplified front edge, we're now free to experiment with overlaying multiple waterfalls and seeing where the load time of individual assets start to spread out. And we can see the variation where the HTML requests at the top are very consistent, but we get diversity through our waterfall, even though they're all very consistent in terms of the overall page load time. And if we take another step and start to bring in the width of those resources and overlay them and give them transparency, we're almost starting to try and build a bit of a heat map kind of diagram of multiple waterfalls laid over the top of each other. And this can tell us a little bit about the construction of a web page and where the weight is in that page load. Now, I happen to know that this is a page that does a whole lot of lazy loading of images. I'm sure I don't need to explain to you where that lazy loading happens. You can see it really clearly in the later half of this heat map. So it's really interesting how even these very, very simple visuals can start to paint a picture about a web page and how it loads. So before we get in there and start playing and seeing where the data might lead us, it's really important to talk about play and creativity, because these are the tools that you need to use along with your data. And play is such an important part of discovering how the world works. I wanted to explore and generate lots of experiments. Some of the ones that I'll show you today I think are complete failures. Other ones I think have some kind of merit. But the point is to kind of play and generate lots of different directions, and then iterate through those and improve them as you go and create more meaning. So I'm just going to switch over to the web page where I've got all these experiments. If you want to follow along at all, you can go to lab.speedcurve.com either now or afterwards and play with any of these yourself. So let me just switch over here. Here we go. So with that spirit of play, I just kind of dived in, and each of these experiments, I mean, I spent kind of 1 or 2 hours on. They're all constructed using dirty processes, right? So these are complete hacks. There's no libraries here, there's no frameworks. All the visualizations you see today are just divs with inline styles. And something that's impressed me through this process, and you'll see some of these we are rendering tens of thousands of divs into an HTML browser. And in some ways, it's really testament to the way that Chrome can actually, visualize its own performance is really kind of nice. So here we've got just that waterfall chart. We're doing things where we're highlighting the front edge so we can get a sense of that waterfall. And something that has frustrated me with the traditional waterfall is that having the list down the side really constrains what you can do with the visuals. So here I've switched to a bit more of a kind of a heads-up display where as you roll over assets, you can see a little bit of information about what it is. We're using the classic sort of content types here to encode for color. So that's just one waterfall, and extending on the model that I showed before, I wanted to kind of think about, well, what does a page look like over time when it gets loaded multiple times over the course of different days, and can you stack these up to get some meaning? So that's kind of 10 waterfalls, and again, we can start to see some different shapes. You can kind of scroll through. Again, you can see some of that lazy loading that's happening down there, and we're using a consistent height here. So the next thing I wanted to do is, being a designer, like one of the things that I have a bit more control over is the size of assets. So I'm not very focused on back end, I'm focused on that 80% of front end performance. So controlling the number of requests and the size of requests is something that I try and understand about the performance of the sites that I'm building. So what I've done here is that we're using color to encode our content type. The width is the time and the duration that it took to load that resource, but now height is actually the size of that resource. And as you scan down these overlaid waterfalls, you start to get a real feel for how a page actually loads. So we can see up in the top here, here's the HTML coming in, here's a whole lot of CSS. We see packets of content coming in here, here's all our web fonts. And then towards the end of the page, you start to see all these little kind of blips. And these are all your retargeting, pixel requests that are going out to dozens of different ad providers. So in quite a visual way, you can start to get a feel for where is the weight in a page. And the last time I gave this talk, someone said, well, have you done more than that? And so last night, after a few beers at 1 o'clock in the morning, because I'm still on New Zealand time, I thought, okay, well, let's do 100 waterfalls. What does that look like? So this is 100 days of individual waterfalls overlaid over the top of each other for a page. I mean, you can see how these start to kind of break. You layer up so much stuff that it just, becomes unreadable. But, I think even zooming out of this a little bit, you still get an overall feel for that page. And where is the consistency? And it's still interesting to see how consistent the HTML is for those 100 requests, those 100 tests over 100 days, and where the groups are coming through, and our vertical lines, so green is our start render, how distributed is that start render over those 100 days, and then our DOM sort of loaded, how wide is that kind of band. So you're almost getting sort of histogram-like visual interpretations from this data. And then I kind of wanted to move on from that experiment and just go right back to, let's not overlay things, but let's just take a simple waterfall. We've got that heads-up display. What can we do with it now? And seeing these sorts of requests really triggered a light bulb for me, because you see really explicit performance problems here. So you look at this and you can see, okay, well, there's a big blob of JavaScript. That's kind of fine. Here's my rendering line, the green line. What's blocking those requests? And then I look at this and I go, hey, what's this tiny little request here? What's going on with this? This is quite odd. Here's a tiny request, only 35 bytes, but yet it took 600 milliseconds to load. And so the form of this, where we're using height to give us a sense of scale, helps us interpret the waterfall. And you can imagine giving this to visual designers or other people and going, look, here are some simple rules for how you might read a visual like this. Long, slow trains are bad. There's small requests that are taking a long time. There's an issue there that needs to be looked at. Versus tall skyscrapers, where actually large assets being delivered really quickly. So the dimension of time and size here actually starts to help you identify issues, which you wouldn't necessarily see these issues in a traditional waterfall chart. Here's another example, and again, you see those very small pixel requests come through, and the lazy loading kind of happening here after start render. Now, another thing that I wanted to do was go, okay, well, that's all well and good, but I'm still scrolling up and down. It's still hard to get an overall picture of performance. And something that I love as a visualization technique are spark lines, which give you a hint of the data and where there might be issues. And so this is sort of an exaggerated version of a spark line, but here I've taken all those requests and I've just collapsed them down to the same horizon. So now things are laid over the top of each other, and we can see the start render, and we can see all our content get loaded in here. And again, we see the same performance issue where we've got that single request that was creating what I think of as a canyon in your request data. And so if you're using all your browser pipelines efficiently and you're pumping all that data through into the browser, you'd expect this to be, you want it to be solid all the way through. We're delivering stuff as fast as possible. So when you look across this and you see canyons in here, you go, well, what's happening here? Is there a single blocking request that is actually delaying the start render? And I haven't had a chance to do it, but mapping CPU usage that comes out of web page test over the top of this would be really interesting as well. Because you'd probably see this gap in here is potentially all the content is being downloaded, but now it's being parsed. And so is there a delay there that's being caused just by the CPU being maxed out, kind of parsing content and kind of rendering it before it then continues on to download more requests? So a visual like this, you could imagine, being scaled down and compared to each other. And in fact, that's what I've got here, where we can now compare two of these sort of visualizations for Smashing Magazine, which has been doing some fantastic performance work towards the later half of last year. And I've been monitoring them for a bunch of time. And you can see here, it's quite a simple page. There's a massive amount of CSS that they lazy load in here. You can see all their image requests. You can see there's some blocking JavaScript, the HTML, and the start render line. And so I was really interested to see whether a visual like this could capture the work that they've been doing. And so if we look at what happened after they relaunched their website, and we move backwards and forwards between these two visualizations, you can actually really start to see quite easily what did they change. And so we can see here that they moved that JavaScript file and they made it a deferring load. And so now the only thing blocking our start render time is the HTML. And as soon as we've got the HTML, they're able to render. And that request has now moved back in here. The other thing we can see is that they've done a much better job of optimizing their images and delivering images that are really well tuned to the user experience. And so it really interests me that a simple visualization like this and toggling backwards and forwards between a couple of deployments can very quickly at a glance give you a sense of where there may or may not be issues. And it's something else that I've been wanting to do for a while is diff a series of waterfalls and try and understand, are there particular resources that are causing us concern? So here I've taken a number of web page tests and I've overlaid the individual resources over the top of each other, grouped them together and given them some transparency. And so what we're looking at here is how blurry is the right-hand side of this graph. So we've got size, which is very consistent. So you can see here these assets aren't really changing in size. But yet on the right-hand side here, we can see our HTML is very consistent. There was one outlier, which is giving it a slight transparency underneath. But then we have other requests like this, where we see quite a distribution of time. And that can tell us about the consistency of our performance from our backend versus CDN providers or JavaScript that's coming from a third party. How consistent are they? So it's quite interesting, the sort of information that you can encode and pull out. And the point here is to create lots of different visualizations to tell different stories, rather than just having one monolithic waterfall chart, which we try and get all the same information out of. And in that same vein, this was another one that really interested me. So quite often I was harassing my design and development team to go, well, you say that you're sharing assets across across the templates on a website, and we've got good code reuse, and you say that it's all being kind of cached on the origin server. But what's actually happening by the time it goes out through those various CDNs? Like, are they honouring, the caching rules that we've got in place? And what is the user experience? What is the browser actually experience of our website? So it's quite simple just to loop through all the resources on a page, look at their cache times, and start to build different views of a website. And we can see differences here between websites that are quite dramatic. And the second one here is actually the Guardian newspaper. And it actually tells you about the editorial decisions that they're making, because they have a huge amount of content here that's only cached for a day. And that makes sense, right? They're a news organisation, the news expires quite quickly. We don't want that hanging around in people's browsers, potentially filling up the cache. So a lot of their images, for that reason and also for copyright reasons, get expired after a day. And you can see that in these simple visualizations. And so I took that model of, well, that's just one page. Now that we're doing tests across a variety of templates on your website, we can start to look at all those resources and compare them across your website. So here we're seeing individual resources, and we've grouped them together into these shared layers. So the top layer here are resources that are used across all these templates. We see how big they are. We see what their cache state is. So ideally what we're looking for here is lots of blue for those shared resources. So red is bad because it's not cached at all. So that means that every time you go to a different page on your website, you're re-requesting those assets again and again. And it was through building views like this that you discover quite interesting problems. So on this particular website, this really interested me, where there's a bunch of CSS here, 220K on the homepage that's unique to the homepage. Over here on this template, we can see that it's used 2 times, which is great, but it's also 220 of like CSS. What's going on there? And then there's another unique one here on the search page. And so I look at that and go, is there a problem here? There's 3 different CSS files that are all 220K. Are they really unique to that template? Or is this a problem with the caching that they've got in place and that they're actually generating unique URLs when they shouldn't be? Because there might be a chance that someone's just made a slight change to a style in one of those templates and that's generated a whole new CSS file. But if I'm traveling across this website and I'm going from the homepage to an article and then I'm doing a search, I'm downloading 3 lots of CSS. So it's quite interesting how these simple visualizations can highlight those performance issues. And then for me, this is an example where this starts to break, where we're starting to encode too much information into a visual. Here we're grouping, we're weighting things in terms of height, and we've brought back in the time, and this is just kind of too much. But I think it's interesting to always push these techniques and see where they break. And there's other things that we can do with web page tests to try and identify issues. So responsive design is a really important technique, and it's a technique that's been talked about a lot over the last 2 or 3 years. But it's really interesting how many sites do responsive design and they think about their visual breakpoints, so they adjust the UI. And we're all guilty of this. I did in the first few redesigns, which I did as well, where we took the desktop site, we designed all our UI patterns for different viewport widths, but all we did for our images is that we took an image and we made it 100% scalable so that it would flex up and down. But we were delivering the same asset. Didn't matter whether you're on desktop or whether you're on mobile. And this has been a really common problem that we've seen with responsive design, where mobile websites have actually totally ballooned in size because people are pushing the same assets through. So I built this kind of visualization because I really wanted to understand, well, how does a website actually respond? So here we've loaded the same page at 18 different viewport widths, and we're just looking at simple things like content sizes. And this starts to give us a feel for not the visual breakpoints, but I like to think of them as the asset breakpoints in a responsive design. And we can see here that for this particular website, around here at 1024, they're making a change from more mobile style kind of images through to their desktop kind of larger images. So they're applying a proper responsive images approach. And we can see down here that they're even conditionally loading their CSS. So they're making a decision on which CSS styles in JavaScript we should load for mobile versus desktop, rather than just munging them all together and delivering it to everybody. So these visuals can really help you keep a track of how your development teams are actually constructing and putting together these different designs. And so here's another one which I love, which is actually taking that performance data, and in this case we're using the resource timing spec, and pulling that through into the front end and turning that into a bookmarklet that we can give to other people in the organization or to front-end designers, and actually demonstrate when content loaded on a site. And here you can see, which is probably not an uncommon issue, that the ads in blue over there loaded a lot later than our hero images. And is that a good thing or a bad thing? And did we expect that? So after the last time I created this talk, it was fantastic. Steve Souders was so inspired that night he kind of was up all night and he coded a bookmarklet for me to take the resource timing spec and apply that into a bookmarklet. So the links are on the website there. You can go and grab it. And I'm going to be a bit cheeky here, but I'm going to show Sosta's website that they just launched yesterday, which is like a great website. But even them, they're suffering from this hero image display problem, where you can see now that we've turned on this bookmarklet, a heat map of their images and how they load. And you see interesting issues here where even though this is a static image, they're using a library to load from a carousel. And we can see that that actually comes in a lot later than other images. So other images that are down here, loaded further in the page, are actually loading a lot quicker and faster than the hero content at the top. So this would make you rethink, well, if it's only a single image, let's not use that library. Let's make sure it's inlined on the website and it's available. And then there's other things that I've been trying to do as well, bringing that user experience in the film strip back into our waterfall data. So here we can scrub across and move up and down our waterfall data and really see when that start render happens and what are all the requests that may or may not be kind of blocking that. So again, just trying to really create that connection between a user experience and its performance data. And again, performance budgets, think about how you bring that kind of content through and display it. Oop, don't want to be there. So just to summarise, really what I'm trying to demonstrate here is that we need, many stories, and to do that we need many charts and different types of visualisations. And you really need to be thinking about who that audience is and selecting the right visualisation to tell the right story. I'd really encourage you to get in there and start working with this data yourself. Like I've said, these are just really dirty techniques. I didn't spend more than an hour or two manipulating this data, so don't wait for people like me or kind of Brendan to do this. We should all be in there creating these sorts of visualizations and highlighting the specific issues that we're seeing in a visual way. So think about who's around your campfire, the questions they have, and those data stories that you're trying to tell. Don't just tell them about the performance issues, show them, visualize it for them. And if you really want them to understand what's going on, then build them a tool that they can actually interact with that data and manipulate it so that they can directly experience it themselves. So if you want to have a play with any of these visualizations, you can go to lab.speedcurve.com. I'd love your feedback on these visualizations. So send me a tweet, stop me in the hall. And in fact, before you all run away, why don't you get out your Velocity apps, give me a rating and just put in a one-line comment of the visualization that you responded to the most. I'd love your feedback and enjoy the rest of your Velocity. Thank you.